Okay, so we're going to work on building a game using an 8x8 RGB LED panel as well as one of these joysticks, and we'll try to add some sound to it later. And we'll start off really simple here, and then as our game becomes more complex, we're going to kind of expand it to some more advanced, I guess, at least for beginner concepts, to make some of the stuff easier for us. So but this is the basic wiring. So you have the panel connected. I've got it on pin 3, but you can move it to wherever, right? So maybe like, oops, kill all my wires here. Oh, there we go. We'll go to pin, there you go. So I've got on pin 8 here, and so you can wire it however. And eventually we'll add in a speaker too. And so the basic thing we're going to do first is we're going to get it so that we can use the joystick to control a dot and move it around on the screen. Okay, and so in order to do so, we're going to be using the Adafruit Neomatrix library, which is a library that basically, because the LED matrix is just an LED strip wrapped kind of snake back and forth that we're using, and so it's just a library that's designed to take that snaked LED strip and treat it as if it was a display, and you have like X and Y coordinates. Okay, so I've gone ahead and pasted in some code here to get us started. We have our Neomatrix library up here included. We have macros to define the width and height of our LED matrix, so 8x8, connected to pin 3, it looks like. And then here is the initialization of the matrix object. Now, so we have the width, the height, and the pin number, and then there's a value here that represents the matrix setup. And so we are going to say that the first pixel is at the bottom left, and you can change this to say top right, etc. We're going to say that it's organized in rows and that the pattern is a zigzag. Okay, you can open up the library and look at the examples to see other options for organizing this. And then this is the same setup, the Neo GRB plus the 800 kilohertz. And so these are kind of the same we use normally with the LED strip. Okay, and then I've got just a colors variable here, or a colors array, so we can pull colors from it, and we'll do more with that later. And so it's just called colors, and it's got 3 colors in it: the red, the green, and the blue. And then here I've got initialized the 2 pins that we're going to use for the analog sensor on the joystick, the A0 and the A1, and that's all we use for now. Then we're going to, in the setup, we are going to initialize the LED strip, or the panel, and we're going to initialize the serial monitor, and then we're just going to take readings from the sensor and print them on the screen. Okay, and so I've gone ahead and upload this code using the Arduino IDE, and so let me pull up the monitor for that. And here we go, we're getting these readings, and when I move it left, it goes to high. When I move it right, it goes to low there for X, up, and down like that. And so that gives us a kind of idea, and so we're going to use that to control motion on the screen. Okay, so the next thing we'll do is we're going to take that information and we're going to turn it into motion. Okay, and so the first thing we'll do is we're going to create 2 coordinates. We'll say the X, we'll just call it X, and we'll start at 0, and Y, and these will be our X and Y coordinates. So we're going to change this later because this is not the best way to do things, but it's an easy way to get started. Okay. Alright, so we've pasted in a few more things here. We went ahead and added a refresh delay, so it's going to kind of update the screen every 400 milliseconds. And what we're going to do now is we have our X and Y variable, and we're going to take readings from our analog sensors, and if they're underneath a certain value, we'll move them down, or if it's over the vertical value, we'll move up, and the same thing here with the X value. Then we're going to take our display and we're going to set the screen to off. So we're going to fill it with the color off, and then we're going to draw the oh, and there's a couple typos here, so I apologize. We're going to go ahead and draw the pixel XY with the color 0, so that'll be red, and then we're going to show it. Okay, and then you'll be able to see the coordinate on the serial monitor. Okay, so let's go ahead and give it a try. Here we have the serial monitor in the background. Okay, so coordinates at 0, 0. And so we can see here that we can control this dot by moving the joystick. Now you can see that if I move left, it goes left, and I go right, it goes right. But if I go up, it's going down. So I'll have to fix the Y. And you can also see we have this issue where if I do it too many times, it goes off the edge. And so we're going to figure out how to wrap it back around so it doesn't go off the edge, right? So we get past 3 or past 8, and then it disappears. So we're going to end up switching these values. So we're going to move we're going to say to increase the value for Y if it's less than 400, and vice versa. And you might have to do some tweaking like this on your own with your sensors depending on how you wired it. Okay, and you might have to reverse the pins or something. Might have to do some filling to get it to work. Also, initially I was thinking it would turn on the LED in the bottom left corner when it started, and it didn't. And so I think there's something a little bit wonky with this, with the equations going on in the background. But all it means is that we're not going to quite get the coordinate we expect, which for what we're going to do is going to be okay. So what's next is we want to go ahead and say if the Y value is greater than the height or equal to, right, if it gets to 8, it will go off the screen. We'll set Y equal to 0. And we'll do the same thing here for X, where if X is greater than the width, we'll set it equal to 0. And then for Y, if Y gets to be less than 0, we will set Y to be equal to the height minus 1, and do the same thing for X. If X is less than 0, we'll set it to width minus 1. Okay, and now this will allow us to wrap around the screen. And we can see here, now I can control this thing. If I go up, it's going to wrap around. If I go left, it's going to wrap around. And now I've got a dot that we can move around on the screen. Okay, so we have it now that we can move the point around on the screen, and we're going to be able to, we're going to go now and we'll do some more stuff with it. But first, it would be helpful to kind of take some of these things that we're doing. So the goal right now is to make it so we can chase, there'll be like a dot that pops up and we go catch it, and then another one will pop up. And so as we have more and more things that we're keeping track of, we're going to end up with a really kind of messy amount of variables here. And so one of the ways that we can work around that is to create our own data types, our own structure. So we have data types in integers and floats, and this matrix is a data type. And so we can actually create our own with something called a struct. And there's other ways we can do this too, which we'll do later. But for now, we're going to make a struct called point. And the point is just going to be an X and a Y. And what it's going to do is going to kind of keep these things together in this like organizational device. Semicolons here and then semicolon here. Now we have a data type called a point, and we'll make an instance of this point. So we'll call it point, and we'll use lowercase point for our name. And then what we'll do is we'll get some brackets here and put a 0, 0 in there like that. And that's going to replace our X and our Y here. Okay, and so anyway, time we reference those, we're going to say point.y right there, and right here, and right there. there, and there, and there, there, and there, and there. And so what this does is now those values belong to that point. And so if we wanted to add another point, then we could do that very easily. Okay? And so the next thing we're going to do is we're going to take all these things and turn them into functions. So I'm actually going to pause it and do that, and I'll go ahead and kind of show what we've done. Okay, so I had a quick little mistake here. So struct, when we make a struct, the keyword actually doesn't have a capital S. So that was a mistake that I had made. So we made our point though. We initialized our first one here, and then I also took the movements and put them in functions. And so we take the point and we send it to the function. And so like move up is going to call this move up function. It's going to take the point. It's going to increase the y value. If it's greater than the height, it'll set it back to 0, and then it returns that new point that we created. Now there's other ways to do this, and if you have like a really big data structure, there's more efficient ways to do this, but for now we're okay. And so we do this with all those. And so now the next step is to add another piece or another dot on the screen that will represent the food. So we're going to make a second point here. So we'll say point food. And we're just going to initialize it to 0, but we'll change it very shortly. Okay, and then we'll make a function to generate food. And what this is going to do is it's going to come up with a random value, and it'll take that value and it'll assign the food to it. So we also have to do some work here with the random library. Okay, so we've made some adjustments here. We went ahead and we declared a second point variable. So this one's called food. I initialized it to 0, 0. We are going to jump down here to the bottom to some functions that I wrote. We have a function called generate food that's going to pick basically a random value that represents a pixel on the display. And then we have another function here that's going to take that number and turn it into a point. And so we pass that number to this pixel a point. We're going to do some math with it to get an x and y value. And then we're going to return that point to this function that we then return to that call for generate food. Okay? There's one other thing we have here is we have a compare function, so we can compare if 2 points are the same. Now, if we're using like an integer, if I want to know if 2 integers are the same, I can say 1 equal double equal 2, and I can use that to see if they're the same as a comparison. But with a basically like a custom type, which is what this is, I can't just do that comparison. So I have to build in a function to do that comparison for me. And we'll see later that there's a simpler way that we can do this. But for now, this is what we're going to do. We call that compare function anytime we want to see if they're the same. And so what will happen is we'll start off by randomly generating. So we have used this line here to generate, to basically seed our random number generator. And so it's got basically a lookup table. And it's going to just start right at the beginning of that lookup table to get the first number. Then it's going to jump to the next one and so on. And so what we can do is if we seed it, then we pick a sort of a random spot on that table as a starting point, because otherwise, if you didn't, you can get the same pattern of values every time you start up the microcontroller. Okay, so we're going to generate some food, and then we're going to still move around, and then after we take our movement, we're going to do a comparison to see if the point that we're currently at is the same point that the food is, and if it is, we're going to go ahead and generate some more food, so we'll move it to a different spot. Okay, then we'll fill the screen, and now we're going to draw both the point and the food, okay, and then show it. All right, and so we run this, and then we get a little bit more of a game here where we can kind of chase this guy around. And so we see here, right, we can move this thing around. We got it. So come get him here. And now you can see we're just chasing this guy around the screen. It's having some trouble. There we go. And so we got the makings of a game here.
Now, one thing that you'll notice is I'm having trouble like controlling it a little bit because the it has that 400 millisecond delay for the refresh, which is maybe a little bit long. But also what happens is that the it's hard to know what the timing of it. And actually one way that we can figure out that timing and also make the game a little bit more fun is to add some sound. Okay, and so our next step is going to be to add some sound to the game. Maybe before that we'll do some organization with our data structure though.